Okay, so today we're going to continue on from the trig review. This is just a little extension of that. So we're starting with using your calculator. You should be familiar with this from your review, but we'll go over it again. So we want to evaluate, round your answer to 4 decimal places. So the first one, we have cos 40. So in your calculator, I'm going to be putting 40 and then pressing cos. A reminder, make sure you are in degrees and your calculator does not say radians. So we get 0.76604. We want to round to 4 decimal places. So we're looking at that 5th decimal place and deciding whether we're going to be rounding up here or leaving the number the same. Since we have a 4 beside it, we're leaving the 0 the same. So we can just erase this off at the end, and that's our answer. The second one is sine 27. So in my calculator, I'm putting 27 sine. And we get 0.45399. We want 4 decimal places. We look at that 5th spot, see if we're going to be rounding up or leaving it the same. Since that's a 9, we want to round up. Rounding up the 9, we'll actually round this here. So we're going to end up with 0.4540. Find the measure of each angle to 1 decimal place. So with these ones here, we have sine A equals 0.4384. We need to get angle A by itself, meaning we need to move sine to the other side. Reminder, when you move sine to the other side, it becomes a sine inverse. So A will equal sine inverse of that 0.4384 decimal number. And to put that in the calculator, 0.4384, and I'm pressing second. You might have a shift button instead to get to the inverse sine button. And we get 26.001. Rounding to 1 decimal place puts us at 26.0 degrees. Okay, the next one, cos B equals 0.6946. Again, to get the angle by itself, you want to move cos to the other side. It'll become a cos inverse. So angle B is equal to cos inverse of 0.6946. Okay, in the calculator, put the decimal number, pressing second, and the cos inverse, getting 46.00. So no need to round up, we leave it the same, 46.0 degrees. That's our answer. Similarly here, we have tan of angle D equals 1.887. To find the angle, we need to move tan to the other side. It'll be a tan inverse. So angle D is equal to tan inverse of 1.887. And that angle is 62.07. 7 is higher than 5, so we need to round that decimal number up. So we will get 62.1 degrees. Here, solve for the unknown angle. Round to the nearest degree. To do this, we want to label our sides. So if our angle's here, we have our hypotenuse as our longest side across from the 90 degree. The side that is beside the angle is the adjacent side. Okay, so using Sohcahtoa, we are using the adjacent and hypotenuse, and that means we are going to use cos. So cos theta is equal to adjacent over hypotenuse. Cos theta is equal to, the adjacent is 5, the hypotenuse is 7. In order to get the theta, the angle by itself, we need to move the cos to the other side. It'll be a cos inverse, so theta equals cos inverse of 5 over 7. In my calculator, I'm putting 5 divided by 7 equals, and then pressing second and inverse cos. We want to round to the nearest degree. So we have 44.4. Rounding to the nearest degree, since it's a 0.4 on the end, we leave it the same. So we have 44 degrees. Looking at the second example, we have theta, and we want to label our sides according to that angle. So across from theta, that is our opposite side, and across from the 90 degree is the hypotenuse. Since we have O and H, we are going to be using sine. So sine theta is equal to O over H. Putting in the values that we know, sine theta is equal to, the opposite is 3, the hypotenuse is 4. To get theta by itself, we move sine to the other side. We will have theta equals sine inverse of 3 over 4. In my calculator, 3 divided by 4 equals, and second, sine inverse. So here we have 48.5. Because of that 0.5 on the end, we are going to round up. So we have 49 degrees. Okay, similar examples here. Solving for the unknown angle, round to the nearest degree. So in respect to theta here, we have the adjacent side and the opposite side. Adjacent is here, opposite's here. Because we have the opposite and adjacent, from Sohcahtoa, we know we're going to use tan. So tan theta equals O over A. Putting in what we know, our opposite is 8 and our adjacent is 7. Getting theta by itself, we move tan over, it becomes a tan inverse 8 over 7. Our theta is equal to, we're going to put 8 divided by 7 equals, and second, to get tan inverse, we get 48.8. Rounding to the nearest degree with the 0.8 on the end, we're rounding up, we get 49 degrees. Next one, looking at theta, we have the adjacent side, and we have our longest side across from our 90 degree, which is our hypotenuse. So A and H. We know if we have adjacent and hypotenuse, it's cosine. Cosine theta, A over H. Putting in what you know, cosine theta, adjacent is 1.5. Hypotenuse is 5.5. Getting theta by itself, we'll have cosine, the inverse, 1.5 over 5.5. In my calculator, I'm putting 1.5 divided by 5.5 equals, and second cos inverse, getting 74.1. The 0.1 means I'm leaving it the same, so 74 degrees. Solving triangles, determine all unknown angles and sides. So solve triangle ABC round to one decimal place. So looking at all unknown angles and sides, we can remember that the angles add to 180 degrees. So looking at the angles in the triangle here, we have a 90 degree, a 50 degree. So we can figure out angle B by taking our 180 sum and subtracting the two angles we know, so the 90 and the 50. And we are left with 40 degrees. Now we can look at finding sides B and A based on having this angle of 50 degrees and the hypotenuse of 14. So in respect to this angle, this is the adjacent side and the A is the opposite side. This is O, this is A, the adjacent. So to find side B, we have adjacent and hypotenuse, which means we are using cos. Cos theta equals A over H. Cos, we're using the 50 degrees. The adjacent side I labeled as B, and the hypotenuse is 14. To get the adjacent by itself, that's getting the B by itself, we want to move the divide by 14 to the other side. So it will be 14 times cos 50 equals B. In my calculator, I am putting 50 cos times 14. And we want to round to one decimal place. I have an answer of 8.99, and that rounded will bring me to 9 meters. Now to find the last side, the A or the opposite side, using opposite and hypotenuse, that means we are using sine. Sine theta equals opposite over hypotenuse. Sine of the 50 degrees, our opposite is side A, and our hypotenuse we know is a length of 14. Similarly here to solve, we want to move the divide by 14 to the other side, meaning it will become multiply. So 14 times sine 50 equals side A. So 50 sine times 14, we get 10.72. We need one decimal place. The 2 beside the 7 means we're keeping it the same. So we get 10.7 meters as the length of side A. I'm going to leave this one up to you guys to try, and I will post the solutions after. So looking at this, solving for triangle ABC, you want to figure out the unknown angle, so you want to figure out what angle A is. You're given side A of 12 meters. You want to find side B and side C. Again, make sure you are rounding to 1 decimal place. When the question specifically is asking for a decimal place to be rounded to, that is what I'm looking for. That's part of your communication mark, so I need to see the proper rounding of your decimals. Okay, now we're going to be moving into word problems. So there's different steps that you can take to help you solve the problem, as well as steps to ensure that you have the proper answer, and I'm able to see what that answer is based on having a therefore statement. So the steps, we want to draw a picture, we want to label that picture, identify the trig ratio, so what you're going to use from Sohcahtoa. You solve it, and then you write a therefore statement based on what the question is asking. Okay, so we can have different terms when we talk about this. An angle of elevation. This is the angle between the horizontal. So the horizontal is a line that goes across this way, and the line of sight when looking up at an object. Okay, so elevation, it means you're going up. So from the horizontal up to where you are looking, this person is looking to the top of a building here. That angle that's created between those two lines is the angle of elevation. Sally needs to measure the height of her apartment building. She notices that a shadow cast by the building is 102 meters long, and the sun is at an angle of elevation of 53 degrees. How tall is her building? Okay, so there's different things that we have here. We have an apartment building. We have the ground. We need to know the height of the building. So we don't know the height of this building. That's what we need to find. And it's casting a shadow that is 102 meters long. So going from the ground, the horizontal, up to where the sun is, that is 53 degrees. So now we want to figure out how tall the building is. Okay, so we notice that we've created this right angle triangle. We know the measurement down here is 102. We know the angle is 53 degrees, and we want to find this side of our triangle here. So based on the 53 degree angle, the adjacent side is right here, and the opposite side is our x. So if we're dealing with opposite and adjacent, that means we're going to be using tan. So tan theta is equal to opposite over adjacent. Tan of our angle, which is 53, is equal to the opposite is x, it's the height of the building, and the adjacent is the length of the shadow, which is 102. Now we want to solve for x. So we're going to move that divide by 102 to the other side. opposite of divide is multiply. So 102 times tan 53 equals x. In the calculator, I am putting 53 tan times 102 and getting a measure of 135.4, and we are measuring in meters. Okay, so now that I have my solution, I need to make a therefore statement. So the question is asking, how tall is her building? So therefore, her building is 135 meters tall. Okay, so that's using our angle of elevation, and we can also have an angle of depression. So this is going down from the horizontal instead of going up from the horizontal. So again, we have a person, we have the horizontal, and where they are looking to. So between the horizontal and where they're looking to, going down, that is the angle of depression. So Mark stands atop a cliff edge and looks down into a lake. He sees a boat sailing in the water. Using a rangefinder, he determines the boat is 374 meters away in a direct line from his position. Mark knows the cliff he is on is 100 meters tall. Determine the angle of depression from Mark to the boat on the lake. Okay, so we have a cliff that Mark is standing on. We know that this cliff is 100 meters tall. There is a boat sailing in the water. And we know that that boat is 374 meters away. So this is creating a triangle, and our horizontal is here. This will be our angle of depression. From the horizontal to the boat. Okay, so using this here, there's a couple of steps we need to take. So we notice that we have our triangle here. First, we would want to find this angle of the triangle here. We can then use that angle to find the angle of depression. So first step, finding theta here. We want to label the sides of our triangle. So with this as our angle, we have our adjacent as our 100 meters, and we have our opposite going across from theta, which is the distance from the cliff to the boat, which is 374. Using opposite and adjacent, we can use tan again. So tan theta equals opposite over adjacent. Tan theta equals opposite is 374 over adjacent, which is 100. Getting theta by itself, we move tan to the other side. It'll become a tan inverse of the 374 divided by 100. Okay, in my calculator, I'm putting 374 divided by 100 equals, and then second, using the tan inverse, and I get an angle of 75 degrees. Okay, so we found theta here, but we have not found our angle of depression because that is going from a horizontal down. So what do we notice about these two angles here? What do they create? They create a 90-degree angle. So if we know this is 90 degrees, and we also know theta here is 75, we can find, we're going to call it theta 2. We can find theta 2 by doing 90 minus the theta we found, which is 75. Okay, so 90 minus 75 gives us an angle of depression of 15 degrees. Okay, so we have our solution. The last thing we do is make a therefore statement. So therefore, the angle of depression is 15 degrees. Okay, so remember those steps as you're doing your word problems. You want to sketch a diagram, label the sides, and figure out what exactly the question is asking for you to solve for. So I have textbook questions for you here. Page 9, numbers 5, 6, 7, 8, and 11. And we are going to have a trig quiz on Thursday, and it's going to be regarding Sohcahtoa and word problems. Tomorrow you're going to have more practice with word problems, so there will be a fair amount of practice before your quiz. Please let me know if you have any questions.